Hello and welcome to my channel. In this video we will solve the optics exercise of the first session 2017 concerning a converging lens. The aim of this exercise is to determine the focal length of a converging lens. For this we have the lens and its optical axis, the object AB as well as its image A prime, B prime as given by this lens. You are also given that the direction of propagation of light is from left to right, and you are given the scale. Each 2 centimeters are represented by 1 centimeter on the x-axis. On the y-axis you have real scale, so each 1 centimeter is represented by 1 centimeter. This is the first question. The image A prime, B prime is virtual. Justify. Let's go back to the figure. We can justify this by 2 ways. The first way is by saying that A prime, B prime is behind the lens. So this is the lens and A prime, B prime is behind the lens. So it's virtual because a real image is always formed after the lens. Another way to justify that A prime, B prime is virtual is by saying that it's erect relative to AB. And erect means that it's not inverted. So B is above A and B prime is above A prime. So A prime, B prime is virtual because a real image is always inverted. In question 2, we have to reproduce on a graph paper and with the same scale the figure of the above document. In this part, you want to reproduce the figure on your graph paper. So what do? You draw the converging lens and the optical axis. Then you move 3 centimeters graphically away from the lens to draw the object AB. You put A on the optical axis and AB is 1 centimeters on the graph. Then you move 1, 2, 3, 4, 5, 6 centimeters away from A to draw A prime, B prime, where A prime, B prime is 3 centimeters on the graph. That's how you reproduce the figure. Let F be the focal length of the converging lens L. Determine using the path of a luminous ray issued from B and parallel to the optical axis the position of the image focus F prime. So here you have to determine using the path of the ray. It means that you have to draw it and justify your drawing. In this part we want to determine the position of the image focus F prime by drawing a ray of light issued from B and parallel to the optical axis. Light that is parallel to the optical axis continues passing through F prime, but we don't have F prime yet. So how do we continue this ray? Any ray of light that comes from the object point B emerges the lens as if coming from the virtual image B prime. We draw the line here dotted because there is no ray of light here. This is the ray of light and it doesn't go backwards. It just seems to come from B prime. Then we continue this ray until it meets the optical axis at F prime. The point of intersection of this ray and the optical axis is the image focus F prime. Part we want to deduce the focal length F. The focal length is the distance between O and F prime. So we have 1, 2, 3, 4.5 centimeters and we multiply by the scale, which is 2 centimeters, to obtain the focal length of this lens. If you find this video useful, please share it with your grade 9 friends and I'll see you in the next video.